gas. Okay. So this is a degenerate, basically degenerate gas. Okay. Degenerate gas. So ultra relativistic means when the energy of the electron is very high, extremely high, okay, such that its total energy becomes greater than its rest mass energy. Okay, those are called extreme limits or ultra relativistic limits. Okay, so in this case we know the energy is written as a m0 square c4 p square c square. So since E is very high compared to this one, so we can neglect this part and we can simply write that E equals to Pc. Okay, and we can simply P, we know that H cut K, so H cut K C. Okay, so we can write the electron energy as H cut K C. Okay, now we have to find the density of states. Okay, or I am trying to calculate here the pressure. Okay, the pressure of relativistic gas. So in order to calculate the pressure, I need total energy of the system. Okay, and once I know the total energy of the system, I can differentiate this expression by volume and I can get the pressure. Okay, and before I calculate the total energy, I have the n particles, so I need to calculate the average energy. So exactly what we are doing yesterday, same thing you have to repeat again. Okay, so this is the density of states. First calculate density of states. For I'm doing for 3D case. Okay, similarly you can do it for 2D or 1D also. So this is the relativistic gas. Okay, now you know what is the expression for if I want number of k states. Okay, that's simply 2 into 4 by 3 pi k cube upon 2 pi if the L cube. Okay, so there's a n particle in a volume V. Okay, n particle, n electron, n particle in volume V. Okay, so I can simplify this as a 8 by 3 pi k cube. Okay, and then 8 pi cube volume. Okay, 8 cancel, pi square. Okay, so I will have 1 by 3 k cube. Okay, pi square and volume. Okay, now this energy is in terms of k. You can use this relation and you can get the expression of energy number n in terms of energy. Okay, so you have V by 3. Okay, 1 upon pi square. Okay,
Sir,
huh.
why we put V here, sir?
V means V volume, na?
Volume.
V is volume. L cube was there, na? Yeah?
Okay.
This L cube came. Okay, so let me write L cube here. Okay, this L cube already written V, na? Okay, so here V is L cube. Okay, so I'm here V by 3 1 by pi square k cube. Okay, so k will be what? E upon H cut C. Okay, so now calculate what we are doing yesterday, same manner. Okay, you need to calculate the same calculations. Okay, now I have n. Okay, if I want density of state G, that is simply I can do dn by d. Okay, and if you want here, you can find the expression for Fermi energy also. If you put EF, okay, that will solve for density of states. So I want G, okay, that will be dn by de, and that will come out as V upon 3, okay, 1 by pi square. If you differentiate this one, leave it constant as it is, s cube, and e cube will be, if you do it, that will come as 3 e square. So 3 cancel. Now
सर जो आपने जो एन ई निकाला है वो के स्टेट को एनर्जी की फॉर्म में निकाला है ना?
n in the form of energy, number of electron in form of energy, okay, and we know that the total energy is up to EF. So here you can calculate the Fermi energy also, okay. I will do it later, okay. Now I know GE, okay, GE this one. So expression for GEDE, okay, is B by pi square, okay, E square h cut c cube, okay. So here I can know a important results, okay, which you should know. GE is here proportional to E square, okay, in for relativistic particle, okay, for relativistic. So here I'm taking E is greater than m0 square, very. So that means you can also use this relation for massless particle, okay. Which are the massless particle? Which are the massless particle? Photon, okay.
Photon.
So this relation you apply on photons also. The photon also you come this one, okay. So relativistic case, okay. Now you know this E square, okay. Now calculate the Fermi energy. Fermi energy, what Fermi energy will come? If I want to calculate Fermi energy, what is the relation will come? Just calculate. I want to check what you're getting. Okay. So how to calculate Fermi energy? Okay. So we have already if I want to calculate Fermi energy, I know E is h cut k c. If I have Fermi energy, I need to make it this EF, okay. So kf will be what? Here will be what? EF upon h cut c, okay. EF upon h cut c. EF upon h cut c. Or let it be like this only, okay. So EF, okay. Or just now we have written the expression for n, okay. What are the expression for n? Can you repeat what is the expression for n?
V upon 3 pi square
3 pi square
E cube upon h cut cube c cube.
h cube c cube, okay. So if you put it, this is total particle, okay. For relativistic gas, they are all below EF, up to EF only. So I can write here EF also, okay. So this here I can get the value of EF. EF will be what? 3 pi square n, okay, upon V and h cut c. So just take 1 by cube, okay. So this is my Fermi energy. Let me check the answer, okay. So this is h cut pi c 3n upon pi, okay. So okay, now if you solve further, okay, so I can get EF equals to what? I can get here pi square, pi will come out, h cut will come out, okay. C will come out, okay. You have 3 n upon v, you can write n, okay. And pi क्या आ जाएगा? Pi इसका अंदर रहने दो, h cut c, and the volume also here, volume gone here, okay. So 3 pi square and h cut c बाहर आ गया, okay. So
सर एक जगह कंफ्यूजन है।
हाँ
आपने
Power
ये जो
1 by 3.
हाँ
एन से आपने EF निकाला, अभी आपने इधर लेफ्ट हैंड साइड पे नहीं डाला है ना सर?
कहाँ पे? नहीं, मैंने बस यहाँ से निकाला इसको, यहाँ से इसको n की टर्म्स में निकाल लिया फर्मी एनर्जी को।
हाँ सर, अभी आपने इधर सब्स्टिट्यूट वाला काम नहीं किया है ना?
नहीं किया, अभी कुछ नहीं किया।
ओके।
Okay, now you have pi square here. So what I'm doing, I'm dividing by pi, so this becomes pi cube. So this also, so this is the standard way of remembering. Okay, for Fermi energy. Okay, and here already you have one power 3. So this is the correct expression. Okay, so now I have the Fermi energy. You, if you want, you can calculate the Fermi vector also. Okay, now I have density states, and I have so I can calculate. So you can apply same in this case. Okay, Fermi, you can take as a Fermi level is n, Fe equal to 1 in this particular case. Okay, and you can calculate the total energy. Total energy would be what? So E is less than EF. You can calculate Fe equals to 1. So average energy will be what? 1 upon n. Okay, G. Okay, E Fe G D. Okay, from 0 to EF. So 1 by n. Okay, 1 by n, 0 to EF. Okay, E I have, for me I am putting 1, and GD just now I have calculated GD values V upon pi square, V upon pi square. Okay, E square H cut cube C cube. Okay, so this I can put here. Now just integrate that one, that will give you the energy. Okay, now I have this expression for energy. Please remember this formula for EF also. Okay, we'll use that one also. So now I have E. Okay, so I can write average energy as 1 by n. Okay, V constant, pi square constant. Okay, H cut C cube constant, and under this become E cube. Okay, so it will come out as a EF4 power 4 upon 4. Okay, you can integrate this one directly, E cube, and now you have 1 upon n. Okay, V upon pi square. Okay, 1 upon H cut C cut. Okay, you can write EF, and EF cube value was 1 by 3, so you can put value here. So that will come pi cube H cut cube, sorry, yeah, C cube. Yes, C cube. You put the value of E power cube. So pi cube H cut cube C cube. Okay, and then this if you open this one, this will come out 3n. Okay, I'm writing instead of n upon v times, because they are also here, n upon type pi. Okay, v. This pi is not there, na? This pi is not there, na? I already took bar. This pi is not there. So this is
So then this pi will also be not there, na? EF pi you have written, you have multiplied, you said that. Multiplied and divided.
No, here pi square was there. I took pi, I wanted to make it pi cube, so I divided by pi. Okay, I multiplied by pi, so pi cube become pi cube. I brought outside, no?
Okay.
Okay. Now you can see क्या कट रहा है. Okay, so you have
There is a 4.
4 also there. Okay, so n cancel, v cancel. Okay, just, and then pi square, pi cube cancel, everything will cancel, H cube cancel, C cube cancel. You have only 3 upon pi 4 EF. I think this should get, you're getting this one.
Yes.
Okay.
Yes, sir.
So this is the, so this is for relativistic particle in 3D. Okay, similarly you can get this for 2D or 1D also. Now you have this average energy of particle. So, and you know the number of particle also. Okay, so you can calculate the total energy also. Okay, if I ask you to calculate total energy, okay, so total energy will be what? Your N into E. Okay, so like we are doing for relativistic, You can do the same thing for non-elastoistics. Okay, yesterday we did not calculate the pressure, but you find you can calculate similar way. We'll do some problem today. They asked some pressure, so we'll do it for non-elastic case also. So N. Okay, so now you have the energy. Okay, 3/4 N EF. Okay, now you can put the expression for EF or N. Okay, whatever you want. Okay, so I want you put the value of this EF here. So EF value just now we have used. Okay, so EF value was what was the EF value?
Pi,
3 pi
pi h cross c.
Pi h cross c
3n by pi.
3n by pi, 3n by pi v
to the power 1/3.
1/3. Okay, so this is the value. Okay, you have. Okay, so now if you say this 3/4 is constant and 1/3 and here, so this n become 4/3. Okay, and you have pi. Okay, you have h cut c, and then you have inside n already taken, so you have 3 upon pi v. Okay, so 3 upon pi power 1/3. Leave it all things. I need this pressure volume, and volume is 1/3. Okay, all the things are constant. Okay, so I need number and this one. So I have n upon 4/3 and v equal to 1/3. Okay, now I have this total energy. This is total energy. Okay. Now you know the pressure from thermodynamics. Okay, always you can calculate the pressure of the gas. Okay, what is the formula for pressure of gas? Del E upon del V. Okay, Tn. Okay, so if you differentiate this one, this energy with respect to volume, so if you calculate this one V1, okay, so this become minus v power 1 minus 1/3. If you differentiate, it will come minus 1/3 forward. Okay, and again v by 4/3. Okay, so you what will get? You will get 1/3, so you get 1/4. Okay, pi h cut c, these all are constant. Okay, I don't need this constant, and this become n upon 4/3, and my volume also become 4/3. Okay, so my pressure is okay, and this is nothing, this is the density. Okay, so I can write my density is n upon v power 4/3. Okay, and you can write pressure is proportional to density, number density power 4/3, or you can add rho also. Some books write rho also. So n is equal to 4/3. This is the pressure of gas. Okay, so let me
Sir,
check.
here when you've taken this 1/4, then there will be minus. Now you have taken this up in the numerator, or you have done with denominator only?
So if I differentiate 1/3, so this become v, v power minus 1/3, na?
Yes, sir. Then there it will be minus. No?
Now you differentiate, so minus already there, na? Minus become plus.
Okay.
And 1/3 will come, so 3 cancel. So I will left with 1/4. Okay. So we are getting 4/3 or 5/3. Okay. So let me check. Just 4/3 or 5/3. Just 4/3 only. Hmm. 3 pi square. Okay. Here we have 3.
Sir, here in the last what you've written, n equals to n to the power 4/3, no?
Yeah, 4/3. Okay.
So this last one, p is proportional to n.
P is proportional to and number density.
Okay.
Okay. So for the moment, assume this is correct. Okay. Let me check also. I will tell you tomorrow also. It's correct only. Okay. So if there is some something to modify, I will tell you. We are not any calculation mistake here, na? So it should be 4/3 only. Okay. So this is the pressure So the way I have done here for, so energy is correct, up to here is correct. Okay, so the way we have done for 3D, okay, you please try for 2D or 1D also. The same thing calculation, you do it for 2D and 1D. Okay, now let us solve some previous year problems, okay, based on what we have studied so far. Okay, now I have, okay, so a question came in GATE 2016. Okay, so they are saying consider a metal which obey the Sommerfeld model, exactly what we are doing Sommerfeld. So consider a metal which obey the Sommerfeld. Okay, if EF is the Fermi energy of the metal at T is equal to 0 Kelvin. Okay, they say at T is equal to 0 Kelvin. Okay, the Fermi energy is EF. Okay, and we are following Sommerfeld model, that is quantum model. Okay, model, and RH is the Hall coefficient. RH is the Hall coefficient. Okay, Hall coefficient. Then which of the following statement is correct? Okay, so this says RH. You have to show how RH depends on Fermi energy. Okay, relation, they are given 4 options. Okay, so I'm not writing all the 4 options. So say this power X. Okay, they're given 4 options. Okay, so they say they have given different power. So let us find out what is the dependence on this. Okay, so how can we proceed? Anyone? How can we proceed? How can we relate Hall coefficient with Fermi energy?
Sir, RH is equal to 1 by NE होता है.
Very good, very good. बस हो गया, पकड़ लिया. RH is equal to 1 by NE. Okay, and N is what? Number density. Okay, and number density depends on Fermi energy. This is they are not given 1D 2D, so we have to assume 3D case, and we know that is h cut square upon 2m. Okay, and this is 3 pi square n by v 2 power 3. Okay, and so if I were to, so then I have to, if I have to remove this 2, okay, so my density will be obviously proportional to EF power 3 by 2. Okay, so my x should be 3 by 2. Okay, so answer should be here, RH is proportional to 3 by 2. Okay, so let me check gate question 11. Okay, yes, it is correct. E power 3 by 2. So so sorry,
2
minus
by 3 आएगा.
I mean 2 by minus आएगा, minus because we have 1 upon n na, so EF 3 by 2 will come. Okay, so RH will be minus 3 by 2 because 1 by n na, so minus 3 by 2. ठीक है.
Sir, it is 2 by 3 now. How we by 3 by 2?
अरे how 2 by 3 power, if I'm writing x square. Okay, so I suppose I have a x square. Okay, so I can write na x power minus 2.
Okay.
So it's x is equal 3 by 2 minus 3 by 2. Okay, power we cannot change na.
In the formula we have 2 by 3 now, sir.
Which formula? This formula.
Yeah.
So but you have to remove, you want number na, number density. So you have to take, you have to make it 3, you have to multiply by this power by 3 by 2 na. You multiply by 3 by 2, then only it will become 3 by 2 na. So 3 cancel, 2 cancel.
Okay.
Now you have this density, this is proportional to e power 3 by 2.
Okay, sir.
Okay, let us do some more problem. Okay. So just now we've done this same problem. Okay. So say they said the energy, they have given the dispersion relation. Okay. They have given the dispersion relation E equals to C some constant K. Okay. Some dispersion is given and the density of state D is proportional to E power P. Now they're saying the density of state is proportional to E power P. Okay. So the value of P is, okay, they're asking what is the value of P. Calculate. And this is 2 dimension. Okay. They're saying this is in 2 dimension. 2 dimension. So you know how to do it and tell me the answer. Okay. I have given you a direct formula also. You remember that you can apply. Okay, density states. Okay, if you don't remember that one, so this is a 1-minute job. 2 dimension. Okay, so you know 2 dimension, your n is what? N is your 2 into pi k square upon 2 pi upon L square. Okay, so this will become 2 pi k square 4 pi square. Okay, L will become a, pi cancel. Okay, 2 cancel. So I have 1 upon 2 k square pi a. Okay, this is n. Now I want g. G is nothing, dn by de. Okay, so dn by d, before do it dn by d, I need to change this one into, I want to bring this in terms of energy. Okay, so before I differentiate, okay, let me write that n 1 by 2 pi k square is now e square upon c square. Okay, and a also there, a is constant. Okay, now I want, these all are constants. I want g, which is dn by de proportional to e. Okay, if I differentiate this one, so you get e here. So they ask proportional to c only. That means my p is equal to what? 1. Are you getting what I'm doing here?
Yes, sir.
Okay. Or there's a direct formula also. If you remember that one, you can also apply that formula also. Okay. Now we have, is saying this GATE 2012. Okay. They're saying for an ideal Fermi gas in 3 dimension, the electron density in electron velocity Vf at the Fermi surface is related to electron concentration Ns. Okay, so he asking how the Fermi energy in 3D. Okay, Fermi velocity. Okay, the for an ideal Fermi gas. Okay, the electron velocity Vf at Fermi surface is related to electron concentration Ns. Okay, how it is related to electron concentration N. Okay, so बताओ कैसे करेंगे? So let me check the answer and resolve it. Question 5. Okay. Okay. Now, how can we do it? This, how to approach this problem? Your Fermi velocity. Okay. So can I write like this? Fermi momentum is equal to h cut kf. Okay, from there I want velocity vf. I can write h cut kf upon m. Okay, and kf you know, h cut m 3d. So kn is what? 3. Kf is what? 3 pi square n by v power what?
1/3.
1 by 3. Okay, so that means my vf will be proportional to n power 1 by 3 is the answer. Because if you want to see energy is 2 by 3. Okay, because energy is what? Energy is h cut square kf square Fermi energy. Okay, upon 2m. So this is 1 by 3. Correct. Okay, let me solve a few more problems. Just now I have solved one problem. Okay, you could do that one. The total energy E of an ideal non-relativistic gas. Okay, in 3 dimension. So again they are saying just you need to, if you see this type of question, just you to see first dimensions. Okay, so they are given a dimension. Okay, and it's saying that energy is E. Energy is proportional to n power 5 by 3. This is non-relativistic. Okay, 5 by 3, and this is v power 2 by 3. This is given. Okay, energy is given. So you're asking identify the correct gas equation. That means asking pressure. Okay, what is the pressure? What is the pressure for here for given? What is the gas equation? PV. So basically, it's asking about to calculate pressure. Okay, so what should I do now? If I need to calculate
Minus
Delhi by
V
Delhi.
very good. So just minus del E by del V, keeping temperature and number constant. Okay, so if you differentiate this one, okay, so this is this is already proportional, na? So I'm only writing the proportional only. So there will be some constant. If you want, you can write some C here. Okay, now you can put constant C here. Some constant is there C. Okay, now if I calculate this n 5 by 3, okay, and sorry, correct, and 5 by 3, and if I differentiate this one v, so how much will come? Minus 2 by 3. So 2 by 3 will come, 2 by 3 will come, and v again will become v become 5 by 3. Okay, and if you put 1 v here, so this become pv, and here you will left c n power 5 by 3 b power 2 by 3 into 2 by 3. Okay, so pv 2 by 3, and this again is ce. Okay, so they asked which is the gas equation. Okay, so this is the answer. This is, you know, already know, for any gas, non-relativistic gas, pv is equal to always 2 by 3 e in 3 dimension. So this option is given as option B. This is correct answer, option B. Okay. Shall I erase this one?
So please wait.
Now this pressure I have calculated for 2D, 3D. Okay. Now it is homework for you. I already calculated average energy per particle in 1D, 2D. So you have to do homework for, you have to calculate the pressure for 2D, 1D and 2D. Okay. And you have to calculate everything for relative case also, and show me whether you're doing correct or not. Okay. So this is your thing. Okay. So let me erase this one. This is 3D. Okay. So let us solve one more problem. So these are all gate problems. Okay. Now we are going to solve some net problem. Okay, which problems came in net JRF. Okay. So they are asking the dispersion relation is given. Okay, the dispersion relation of a gas of spin half particle, spin half fermion in 2 dimensions. So they are now giving 2 dimensions, 2-dimension case. Okay, so as you can see, they all questions are similar type of questions. Okay, just little bit variation is there, and they are giving h nu, okay, k dispersion relation. This time they are given this one, where E is the energy, K is the wave vector, okay, and V is the constant, with nu is the constant, okay, with the dimension of velocity. Okay, if the Fermi energy at 0 temperature EF, okay, so now at T is equal to 0, they are saying, they are given the Fermi energy, and what they are asking, they're asking the number of particle per unit area. Okay, what are the number of particle per unit, which is 2 dimension. So basically they are asking n by a. So this is very straightforward question. If you know the in 2 dimension, if you know the Fermi, but what we have done Fermi energy, we have done E equals to what, h cut square k square by 2m. Okay, now here relation is different, so you again need to calculate the Fermi energy for 2D for this dispersion relation. Okay, so calculate please. Okay, so I need to calculate first the number of states. Okay, in 2D, that is 2 into pi k square upon 2 pi upon L square. Okay, I should
इसमें
remember.
2 से मल्टीप्लाई करेंगे
स्पिन हाफ पार्टिकल है ना,
सर एक ही पार्टिकल का
नहीं ये बोल रहा है नंबर डेंसिटी चाहिए, और ये बोल रहा है स्पिन हाफ पार्टिकल है, तो स्टेट निकालने के लिए तो हमको फर्मियन तो है ही ना, फर्मियन के लिए तो ऑब्वियसली डीजेनरेसी होगी, स्पिन अप स्पिन डाउन। एक ही पार्टिकल कहाँ बोला है, इसमें बोला है कि नंबर ऑफ पार्टिकल पर यूनिट एरिया कितना है इन टर्म्स ऑफ फर्मी एनर्जी।
ठीक है।
Okay, so now you have n. Okay, so find out directly find out kf from here. Okay, but kf, how can you find out? First you need to find out what this is the relation, na? So okay, directly put the, suppose this is the ef, so this become kf. Okay, so just put n. Okay, n is 2, t is equal to 0 is given. Okay, so all the particle will be on ef up to kf only, so you can write kf also here. Okay, so you can write ef here, so you can put value of kf from here, this equation. So I have a n, I have pi. Okay, I have a 4 pi square. Okay, I have a area a. Okay, and then I have a kf square, and kf square I can write ef square, okay, upon h cut, okay, nu square. Okay, and they asking number of particle, just I want n by a. Okay, so n by a, pi cancel, 2 cancel. Okay, so this should give me what, ef square. Okay, and then 2 pi, okay, h cut nu square. This should be the answer. Let me check. ef square 2 pi nu square h cut nu h cut का स्क्वायर नहीं है यहाँ पे, h cut का स्क्वायर का, हाँ, so just check this, just give me 1 minute, check me this values. Okay, so question number 3, option is correct, D is option. So ef square, हाँ पूछिए. Okay, so this is the answer they are given. Okay, So let me give 5-minute break, just drink water. Okay. So we have solved some couple of problems. Okay, and you can see the answers which questions they coming. Okay, what theory we studied, same based on the theory of questions are coming, and we are getting exact answers also. So what the procedure we have learned, okay, that is, there's no problem, that is exactly correct, because we are not on one problem, we are on several problems. Okay, and the way we have learned, okay, that the theory is, that is the correct way. Okay, now let us solve one or two problem more. Okay, so now this question came in December 2012. Okay, and they are asking that they are given the radius of the Fermi sphere of free electron in a monovalent metal with an FCC structure, in which the volume of the unit cell is a cube. Okay, so what they are asking, find out the radius of Fermi surface. Okay, so you have to find out the radius of Fermi surface. Okay, radius of, say, Fermi surface, you have to find kf. Okay, for the FCC structure, for FCC structure you have to find out the radius of Fermi sphere. Okay, how can we approach this problem? Anyone? Let me check the answer and tell me how can we approach this problem.
फिर डेंसिटी निकाल सकते हैं एफसीसी से.
Very good, very good. Okay, so so FCC में density क्या होती है? We have, and how much, if you see the FCC structure, okay, in FCC structure, okay, you have this one, and for this structure, okay, the N effective is how much? 4. So density will be what? Density will be your n upon a cube. Okay, number of particles, number density. Okay, so, and what is the relation between a and r? A and r in for the Fermi, this one. So we know we have 4r. Okay, 4r equals to root 2a. So if I put this values, 4 upon a cube, okay, a cube, and then this come a cube. Okay, so a cube will be what? 4r. Okay, 4r upon root 2. Okay, or why don't we write this one? A is equal to 2 root 2 r. Okay, so 2 root 2 r. Okay, and cube, this cube. Solve it now further. उसके बाद क्या करना है? let me check one. Give me 1 minute. Okay, this is question 6. Okay. Okay. EF is, so we know the KF. Okay, we need to calculate only KF, na? 4 by a cube. Okay. Okay, simple question. So now KF. Okay, KF is what? What is the value of KF? 3 pi square n upon V. Okay, and power 1 by 3. Okay, just put the value of n by V here. N by V is, this is what number, n by V value. Okay, is 4 upon a cube. So if you put the 4 upon n cube, so this becomes 3 pi square. So this becomes 4 into 3, 12. 12 pi square n. Okay, and this V, and this should be 1 by 3. This should be the answer. 12 pi square n. 12 pi square n नहीं, n तुमने लिख दिया वैल्यू. 12 pi square upon V, and V is here a cube. 12 pi square a cube upon 1 by 3. Okay, check it. ये आंसर आ रहा है कि नहीं आ रहा है? So number, so volume is a cube, n is 4. Just let me correct this one. Okay, so this is what n effective is 4. Okay, n effective is 4, that is n, and volume is, you have a cube. Okay, just put here these things, so this should come this one. Are you getting this question? 12 pi square upon a cube, this answer should come. Any doubt in this question?
No, sir.
So let me solve one more problem. This came in GATE December 2011. Okay, they are asking if the number density of free electron gas in 3 dimension is increased 8 times, then its Fermi temperature will increase. Okay, so they are saying that your number density n. Okay, now n1 is n. Okay, and now n2 is your 8n. Number density is change in 3 dimension. Okay, so what about the Fermi temperature? What about the Fermi temperature? Fermi temperature means T, what will be about TF? So we know the EF is nothing, it is KTF. Okay, तो जितना आपका फर्मी एनर्जी बढ़ेगा, चेंज होगा, उतना ही आपका टेम्परेचर चेंज होगा. Okay, so say second case Fermi energy is EF2, first case Fermi energy is EF1. Okay, so and it's 3D. Okay, so 3D we know 3 pi square n. Okay, power 1 by 3, and this is also 3 pi square. So this is n1, n1 is n. Okay, second case n2, this is 8n. Sorry, this is 8n.
Sir, 3D में 2 by 3 होगा. 3D में तो 2 by 3 होगा.
2 by 3. Okay, 2 by 3. And okay, h cut square upon 2m भी है, वो cancel हो जाएगा. H cut square upon 2m, that will cancel out. Okay, so now Fermi energy will be EF2. Okay, what will be? Okay, बताओ क्या आएगा? So this 2, इसको कैसे लिखते हैं? 2 power 1 by 3. So 2 power 1 by 3 and 2 power cube. Okay, 2 power 3. बाकी तो सब कट ही जाएगा. बाकी तो सब cancel हो जाएगा. All will cancel out. Okay, only here 8 here. So it is 2 power 3. So this will come out and EF1. Okay, so this will come. This will become 4 time. Okay, so my new Fermi energy will be 4 time. Okay, that means my temperature should increase by 4 times. So increase by a factor of 4. Okay, so temperature should be increase by a factor of 4. Okay, so ए आंसर आना चाहिए। ओके, क्वेश्चन 5। ओके, ठीक है, 4 TFR है। ओके, ये क्वेश्चन में डाउट है क्या? क्लियर है ना?
यस सर।
हम्म,
सर ये E इक्वल टू KTF कहाँ से है?
भी एनर्जी तो केटी होती है ना, कोई भी एनर्जी होती है, ओके, वो टेम्परेचर पे डिपेंड करती है। सो यू कैन राइट एनर्जी इन टर्म्स ऑफ टेम्परेचर।
सर here K is KB, Boltzmann constant.
हाँ, दिस इज बोल्ट्जमैन कांस्टेंट, करेक्ट,
Okay, okay.
केबी। Here, EF equal to KBTF means, okay, if you need temperature equivalent to Fermi energy, तो उसके लिए energies आपके energies की KT, so we can calculate this one dimensions, okay. Now you say a thin metal film of 2 dimension, okay, this question came in 15, okay, a thin metal film of 2m, thin, now dimension also given 2m, okay, into 2m, 2 mm, 2 into 2 mm, dimension given, okay, a thin metal film of this contain n number of electrons, and they given they electron contain 4 upon 10 to the power 12 electrons they contain, okay. So they're asking what is the magnitude of Fermi vector, okay, find out magnitude of Fermi vector. आसान है तो, सेंटीमीटर में पूछा है, यास इन सेंटीमीटर्स। And 2D, what is the formula for KF? 2D.
Under root 2 pi n.
Under root 2
Pi n.
pi n. N by A. N is n by A because area. Okay.
पूरा अंडर रूट में है।
Okay. ये पूरा under root में है।
Yes sir.
2 pi n. Okay. So this root 2 pi. Okay. And under root n. So n means n by A. Okay. So n is given 4 to 10 to the power 12. And A is given 2 into 2, 4. You can write in centimeters. They ask centimeters, so you can power 2. Okay. So and power half. So this will be root 2 pi. Okay. 4 to cancel हो ही गया. This become 14. So this comes 10 to the power 7. Okay. And should come Fermi vector 10 centimeters. Or centimeter inverse. Centimeter inverse. Okay. तो ऐसे आसान क्वेश्चन आते हैं। ओके, सो वी हैव सीन कपल ऑफ गेट क्वेश्चन, नेट क्वेश्चन। आप चाहो तो जेस्ट और टीएफआर के क्वेश्चंस भी उठा के देख लो। ओके, वो भी ऐसे ही है। लेट मी सॉल्व वन प्रॉब्लम फ्रॉम जेस्ट। ओके, सो दे से a ideal gas of non-relativistic fermion in 3 dimension is at 0 Kelvin. Okay, so they are asking T is equal to 0 Kelvin. Okay, you have to always see temperature and you have to see dimension. They said 3D, and you have to see whether it is a relativistic or non-relativistic. So it's saying they are saying it is non-relativistic. Okay, so non-relativistic. Okay, when both the number density and the mass of the particles are doubled. Okay, so they're saying what they have changed, they have changed the number density. Okay, so earlier number density is n, then second is number density is n2 is number density is doubled. Okay, and the mass of the particle also doubled. So mass of the particle also they are doubling, m, and second is m2 is 2m. Okay, so they are asking the energy per particle is multiplied by a factor. Energy per particle En, okay, will be multiplied. So say the initial is E1 and next is E2. Okay, so in 3 dimension, what is the energy formula? क्या है? Average energy per particle क्या है 3 dimension में?
3/5 Fermi energy.
3/5 EF. Okay, so say this is now, and second, so let us calculate this one. So energy is 3/5 EF. Okay, so say this is, I am calculating first E1. Okay, so first case E1, so 3/5, and this is 3 dimension, so h cut square 2m. Okay, and I have inside, I have 3 pi square number density power 2/3. Okay, this is the first case, and second case I'm getting E2 3/5 h cut square, they're making this 2m. Okay, so this become 4m. 3 pi square, they are making double, so this 2n power 2/3. Okay, now find out the ratio. क्या आना चाहिए? Okay, so if I calculate now the ratio, okay, E2 by E1, okay, so E2 is, ये तो कैंसिल हो जाएगा, 3/5 okay, so ये सब कैंसिल हो जाएगा ना, let me write here 3/5, okay, h cut square 4m, okay, 3 pi square 2n 2/3, and here we have a 3/5 square h cut square 2m 3 pi square n 2/3. Okay, so 3 by cancel, ये cancel, h cancel, okay, m cancel, okay, h cancel, you have 2 1/2, so 1/2, 3 cancel, pi square cancel, n cancel. Okay, so you have 1/2 and 2 power 2/3. Okay, so that's a 2 power 2/3 minus 1. Okay, and this become what? 2 power minus 1/3. Okay, so this should come answer. This is given 2 power minus 1/3. D option is given. Okay, so check इसको just में, हाँ D आंसर सही दिया है, 2 power minus 1/3. Okay, now let me do last question. Okay, so this question came in this came in 2015, JEST 2015. Okay, so they're asking the for non-interacting fermion in D dimension. Okay, in D dimension, okay, the D dimension, the density of state varies as e power d/2 minus 1. Okay, the Fermi energy, so the Fermi energy EF, okay, of n particles are n. So Fermi is asking Fermi energy in 1D, 2D and 3D, how it depends on n? How Fermi energy depends on n in 1D, 2D, and 3D? It's an awesome question. We have done this one already. Okay, Fermi energy we know in 3D. So see, if you put your D dimension, if you put 3D, 3 here, 3 by 2 minus half, e power half. This is a 3D case. Okay, you put 2 constant. You put here 1 e power minus half. This 1D case. So this formula you should remember. Density state. Okay, for D dimensions. Now they're asking how this Fermi energy depends on number n. Okay, so we know in 3D Fermi energy EF is what? Proportional to n power 2 by 3. And in 2D, 2D में क्या है? 2D में क्या आता है?
तो कांस्टेंट हो जाता है ना 2 by 2 तो
नहीं n का कॉन्सेप्ट है. फर्मी वेक्टर और फर्मी एनर्जी का कॉन्सेप्ट क्या होता है? फर्मी एनर्जी निकालो कितना आता है? कल निकाला है मैंने.
n आता है
उसमें 10 होता है.
n आ रहा है.
कितना आता है? n ओके. n 1D में
n square.
n square.
n square. ओके, n पावर 2 by 3 n square. दैट चेक करो आंसर है कि नहीं है. n पावर 2 by 3 n square. डी ऑप्शन दे रखा है क्वेश्चन 2 में. सही है. तो क्वेश्चंस तो आसान ही है. ओके, नाउ अभी हमारा ये वाला पार्ट तो हो गया है ना. अभी हमको जो हमने फ्री इलेक्ट्रॉन थ्योरी में किया था कि हमारा जो विटमैन फ्रेंच लॉ जो हो रहा था उसमें प्रॉब्लम आ रहा था, मतलब कांस्टेंट का प्रॉब्लम आ रहा था क्योंकि हमने स्पेसिफिकेट करेक्टली कैलकुलेट नहीं किया था. ओके, और हम जो कंडक्टिविटी है इलेक्ट्रिक कंडक्टिविटी उसका एग्जैक्ट फॉर्मूला नहीं बता पा रहे थे और टेम्परेचर डिपेंडेंस नहीं बता पा रहे थे. ओके, तो अभी वो करना है. तो नेक्स्ट क्लास में हम करेंगे थर्मल कंडक्टिविटी और जो इलेक्ट्रिक कंडक्टिविटी है उसको कैसे एक्सप्लेन करेंगे क्वांटम थ्योरी से, वो हम देखेंगे. ओके, लेट मी चेक. अभी कुछ क्वेश्चन बचे हैं तो मुझे लगता है ऑलमोस्ट सारे क्वेश्चन मैंने करा दिए. कुछ क्वेश्चन है कि नहीं है? और कोई क्वेश्चन तुम्हारे पास हो तो भेजना मुझे. ओके, टू डायमेंशन में दे रखा है. ओके, ये क्वेश्चन कर लो जून 16 में, जून 2016. ओके, they are given saying consider electron in graphene. ओके, मोनोलेयर ऑफ ग्राफीन. तो जैसे ही ग्राफीन आ जाए you should understood that is 2 dimension. Graphene is 2 dimensional material. Okay, if the dispersion relation for electron is to be taken E equals to ck. Now E equals to है ck. This is the dispersion relation, E equals to ck. Okay, over the entire k space, then the Fermi energy EF depends on number density power x. निकालो इसको. अभी निकाला ही था इसी तरह क्वेश्चन भी. So rho, so this is number density, rho and okay, they are saying rho, you can write n. निकालो क्या आ रहा है, बताओ निकाल के 2 मिनट में. अच्छा, क्वेश्चन 2.
So half
हाफ आ रहा है. ओके, x शुड कम हाफ. बाकी लोग भी चेक कर बताओ क्या आना चाहिए. अदर प्लीज आल्सो चेक. ओके, नाउ एक क्वेश्चन और अच्छा मिल गया मुझे, ये हमने करा नहीं था. आंसर कम रो पावर हाफ. ओके, यू कैन चेक इट. So one question came, good question. Okay, so this question came in 2018. Okay, so they have given you a semiconductor slab. Okay, they have given you a semiconductor slab. Okay, and they're saying they are flowing a current I in this slab. Okay, they are flowing the current I in the semiconductor slab, and they are applying a magnetic field B perpendicular to this slab. Okay, and it's a p type p dot semiconductor. Okay, so they are flowing a I current equals to 100 milliampere. Okay. I they are flowing 100 milliampere, and the value of B they have given 0.2 Tesla. Okay, and they say when we measure voltage, okay, so they are flowing current. Okay, so they are measuring voltage in x-axis, the current they are flowing. So Vx they are measuring Vx, and they are also measuring the hall voltage Vy also. Okay, Vy they are measuring here. Okay, so they are asking Vx is 2 milliwatt, and Vy is 0.25 millivolt. Okay, so they're asking what is the mobility of hole in semiconductor. Okay, what is the mobility of hole in semiconductor? Now because it's a p-type material, okay, so instead of moving this electron, there will be charge carriers, will be holes. Okay, so you need to calculate the mobility of hole. Okay, so how you can calculate the mobility of hole, anyone, in terms of Hall effect? Hall effect से कैसे निकाल सकते हैं mobility? Can we calculate the mobility using Hall effect? जल्दी से बताओ फॉर्मूला क्या है मोबिलिटी का in terms of Hall coefficient. If we know the measure the Hall effect, what is the formula? Okay, किसी को पता नहीं फॉर्मूला मोबिलिटी का? जल्दी गूगल करके बताओ मोबिलिटी.
E tau by m होता है मुझे तो.
एक मिनट. ओके, मैं भी चेक वेरीफाई कर लूँ. ओके, नहीं थोड़ा सा okay, so mobility up my. Okay, so they're saying, okay, for semiconductor, okay, we have not done this one, we have to do this one also. Okay, so the formula for Hall coefficient RH, okay, in semiconductor they are giving 1 upon En. Okay, mu p minus mu n. Okay, and mu p plus mu n. Now, okay, so how to do this one? Okay, नहीं ऐसा नहीं होगा. ठीक है, किसने कुछ मिस्टेक की. RH if you calculate RH, we should be able to calculate mu p na. So if mu n is greater than mu p, okay, So we can neglect this mu p here, then mu n. Okay, and then okay. So say ये क्वेश्चन होमवर्क है, मैं भी चेक करता हूँ इसको, मैंने देखा है आज ही इसको. ओके, ट्राई दिस क्वेश्चन, आसान होगा. यू कैन कैलकुलेट द मोबिलिटी इन टर्म्स ऑफ हॉल कोएफिशिएंट. ओके, जस्ट गूगल करके देखो क्या आंसर आ रहा है. मोबिलिटी का फॉर्मूला क्या है इन टर्म्स ऑफ हॉल कोएफिशिएंट? मैं तो भूल गया हूँ. जस्ट 1 मिनट. मोबिलिटी फ्रॉम हॉल इफेक्ट.
हॉल कोफिशिएंट डिवाइड बाय रेजिस्टिविटी आ रहा है.
अच्छा, तो बस निकाल दो. हॉल कोएफिशिएंट डिवाइड बाय
रेजिस्टिविटी.
रेजिस्टिविटी. सो हॉल कोएफिशिएंट निकाल ही सकते हो. आपको इनफ चीजें हैं, आपको वोल्टेज सब दे रखा है. ओके, और रेजिस्टिविटी भी निकाल. सैंपल का टाइम सैंपल दे रखा है आपको, क्रॉस सेक्शन दे रहा है, सब दे रखा है. रेजिस्टिविटी कैसे निकालोगे? ओके ओके, चलो होमवर्क करो, इसको ट्राई करो. थोड़ा सा करना पड़ेगा, वरना कल मैं कराऊंगा इसको. ट्राई करो. ओके, सो आई एम स्टॉपिंग हियर नाउ. और ये जिसका हो जाए मुझे एटलीस्ट भेज दो करके. ओके, वरना कल तो मैं कराऊंगा ही. सो आई एम स्टॉपिंग हियर. एनी क्वेश्चन? So I'm stopping here. Okay, thank you very much.